Setting up basic Kubernetes cluster with a single pod and deployment is fine, but what happens when you have multiple pods and services? Some require external access, while others should be protected from it and only be exposed internally. To handle such complex setup, we need to understand Kubernetes networking. Kubernetes networking is the underlying infrastructure that enables communication between containers and pods within the cluster and outside of it. A well-configured Kubernetes networking setup is essential for ensuring high availability, scalability, and security of containerized application. Let's begin with the networking concepts. So first we have these three things: pods, endpoint, and service. I will cover in brief what are these because I have covered them in a separate video which you can check from the I button. So pods are the basic unit of deployment in Kubernetes. Pods contain one or more containers. Services provides a logical abstraction for group of pods, and endpoints are the actual network addresses of pods that can be reached by services. So whenever you create a service, Kubernetes create an endpoint object with the same name as the service and list all the endpoints of the pod. As the pod's IP address keep on changing, these endpoints also keeps on changing. So these resources create distinct networking scenarios such as container to container, in a way, intra-pod communication. Pods share a single network space, allowing containers to communicate with each other using localhost or container's IP address. This scenario is ideal for tightly coupled containers which are dependent on each other, or you can say that you might have one main container and one sidecar container. The port where the application is running inside the container is mentioned in the deployment resource. Next is pod-to-pod networking. Kubernetes assigns a unique IP address to each pod. Pods can discover each other through the IP address service discovery mechanism like DNS or hostname. This is essential for services which are loosely coupled and they do not have to be co-located in the same node. Each pod have their own IP address which they got from the worker node's IP address range. So here we can say that this pod is running inside this node and this B pod is running inside another node because of the IP address correlation. If you want to check out the IP address of the pod, you can try the command kubectl get pods and output wide. Now the next is pod to service networking. Service is not a process like pod, but it is a layer to route the traffic from external resources to a healthy backend pod. Now, how does the service know which pod to transfer the request to? This is done using the selector. In the selector, you define some key value pair, which you also have to write as the labels in the deployment. Service will map the selector from here to the labels from deployment, and that's how service will get to know on which pod to transfer the traffic to. If you see here, for each service that we are defining, we are writing a port. This is the port of the service and it is going to the target port 8000 of the pod. This means whenever the service will get the request at port 8080, it will transfer the request to port 8000. This means there is no confusion whenever you transfer a traffic to a pod. It will decide based on the target port. You can even keep the port and the target port same because service doesn't have any ports occupied. Now here for the type of service, I am defining it as cluster IP type. Now let's see what are the other types of services available in Kubernetes. The first one, which we have just seen, is cluster IP service. This type of service will allow the application to be accessible from within the Kubernetes cluster. This is the default service, so you don't need to mention it during creation. The next one is node port. This type of service attribute will exposes your application to the external traffic using the node ports. Each node in the cluster exposes the service on a specific port. So whenever an external client tries to reach to your service, it will reach out to the exposed node port and then to the underlying service. You have to define node port key as part of the service application. Then the third one is load balancer. This provides external access to your application using load balancer. The load balancer distributes the traffic across multiple pods. Now let's see what is the node port service. Node port service exposes your application to external traffic using the node port. Each node in the cluster exposes the service on a specific port. So whenever an external client tries to reach to your service, it will reach out to the exposed node port and then to the underlying service. You have to define the node port key as part of your service specification. Also, there is a constraint to this node port. Your node port must be within this range, else it will not be acceptable. Once you define the node port service, you don't have to define the cluster IP service because it can be used as cluster IP. In case you have multiple nodes, then the same setup is extended to all the nodes, and each node this port will be occupied for this service. However, this type of service is not recommended because of security. Here we are exposing the cluster nodes directly to the outside client, which is not recommended. The next is load balancer. Load balancer is a type of service which provides external access to a service using load balancer. This load balancer is provided by the cloud services. So whenever we create a load balancer service, the node port and the cluster IP service are created automatically. This is an example for load balancer service. Here you do not need to mention the node port. Kubernetes will provide the port value on its own. So load balancer is an extension of node port and node port is the extension of cluster IP. So this concludes our services part. So we have covered all the three types of services. If you have found this video helpful, please press the like button. Now let's see some of the best practices which should be followed in case you want to use Kubernetes services. First of all, use meaningful names. This might sound simple, but it is highly recommended because when you have multiple backend services, multiple front-end services, naming your service is important, because when you have multiple services working through different ports and application, then the naming convention helps you in segregating your work and develop or test easily without confusion. Selector definition. Use labels to target specific pods for each service. Ensure your selectors accurately match the pods you intend to expose. Choosing the right service type is equally important. As we have just discussed, cluster IP is only accessible inside the cluster, so it can be used for backend services. Node port will expose worker nodes to the public access, so even this has limitation, and it is okay for simple application but not for production. Then comes the load balancer, where you utilize the load balancer provided by the cloud providers. This one also provides features like health check and automatic scaling. Port consistency. Maintain consistency between the service's external port, which are for client access, as well as the target port where the pod is listening to. So you do not have to remember different ports and you might not mismatch them. Service discovery. Leverage service discovery mechanism like DNS to allow pods to discover and communicate with services using their names. Limit access to services using network policies to restrict communication between pods and services as needed. You should use health check for pods by mentioning readiness and liveness probe. This will ensure that the traffic is routed to healthy pods. So in this video, we have discussed about Kubernetes networking scenarios, the types of services that we get with Kubernetes, and the best practices for setting up a Kubernetes networking. If you have any questions regarding this, let me know in the comment section. Thank you.